Here we go. Okay, so this is going to be the program of today. So I'll give up a little introduction. I guess that's what I already did. Then I will do a quick Kunai overview. And then finally we can start doing the exercises. If you look at this table, you will see links. So every time you click on the link, you should be like redirected to the appropriate exercise in the GitHub. So this is convenient. Feel free if you want to take note, basically to clone this Git
Well,
repository. And so yes, basically when you click on a link, you get redirected to the exercise and we can do it. And if you want to take notes, I would advise to basically clone this repository and take notes within the repository and within your clone of it, so which will be easier. So let's start with the Kunai introduction. So here I will just explain a little bit what is Kunai and basically what you can do with it. And most of the things you are going to see inside those slides, we will go through exercises and you will be able to understand deeper what we are going to see. So just to start, I have to use some terminology. So what is basically a security event? I will read the definition. So it's an event happening on a system which may indicate potential security incident. Basically, a log entry that it indicates, for instance, the execution of a given binary can be seen as a security event. What is a security monitoring tool? It's a tool that monitors system or an infrastructure and that generates security events for analysis. So such tool can be an IDS, for instance, or an endpoint detection and response tool, or basically whatever monitoring tool you know. And finally, what is defined by the security visibility? This is the capability or the ability to monitor, detect, and analyze security events. And basically, a company that uses security monitoring software increases its security visibility. So here is a little drawing just showing where we are in the landscape of all the different tools you can find. So there are a variety of tools such as tracing tools. We can think about, I don't know, ftrace, for instance, which is a tracing tools. They're very nice for performance diagnosis, debugging, and basically understanding what a software is doing. We have, on the other side, we have antivirus software, which are basically good at detecting known threats, mainly through signatures. Signatures might be dynamic signatures, and a lot of time they are also static signatures. So directly looking into the, let's say, the binary content of the files. And security monitoring, it's a bit in between, taking basically features from one and another. And basically the goal of the security monitoring tool is to provide the maximum visibility to security events and basically actionable events you can use to detect intrusions into your systems. So what is Kunai? It's basically Linux-based security monitoring tools, and it's aimed to help individuals or organization to increase their security visibility by generating several and sound security events. And we are going to see that a little bit into details. So Just a brief history about this project. So it started end of 2022. This was like kind of a challenge for me and was a good first Rust project. Initially worked on it for a bit more than a year under my own company. And since January 2024, I joined the Circle, so the Incident Response Center of Luxembourg. And I'm continued working on this project in the context of a European co-funded project. And so the reason why I decided to start such a project, it's basically that I got super disappointed by Sysmon for Linux. I don't know if some of you guys are familiar with this software, or maybe more with the Sysmon for Windows, which is for me one of the best free tools that you can find for building your own security visibility on a Windows workstation. Uh, Basically, Microsoft decided to do a Linux version, and it took like forever to start and to be released. And once it got released, basically the project was almost already abandoned. And so that's basically where and when I decided to start working on this project. And even though there are like lots of really, really good ideas in Sysmon and Sysmon for Linux, I was like kind of not really happy with some of those, like the events and the configuration still being in XML and a bit confusing sometimes. And for me, one big mistakes that they've been doing as well when releasing and working on Sysmon for Linux is that they basically ported directly the events existing already on Windows without really thinking whether it made sense to port it to Linux. So many events on Sysmon for Linux, in my opinion, don't really make sense for Linux systems. So basically, there are two main reasons why I decided to start this project. So in short, what can we do with Kunai? You can get high quality security events and perform threat detection, threat hunting, and something which is not listed here. You can definitely use it for forensic analysis and use it as basically trace recording on a workstation or servers so that you can really ease a lot your forensic investigations. For instance, you can monitor events such as execution, process execution, which is named like execve and called execve under Linux. You can monitor shared object being loaded, eBPF program being loaded, some file system activities such as file read, write, renaming, and deletion as well. And something to keep in mind, and which is really important, is that every event is built so that you can actually create a very solid behavioral detection. Um, Something important as well is that the events come in chronological order, which is something which is guaranteed by the tool. It offers also some grouping capabilities, so it's very easy, and this is related to the next point, to track parent and child relationship in the process tree, and this is very
Robert,
convenient.
Robert,
Or
wow, مثلا صوت بحياتي. Yeah,
again,
but
someone
مثلا
speaking.
أبلغ.
Sorry. Okay. Um, where I was. Okay. And finally, it's been designed also to track the activity within Linux containers, which means that you should see basically really the same events as you see on your host, and you see the same events for the Linux containers running on a given host, which is very convenient nowadays where everything is running inside containers. So here is a little example of an execv event. You will notice that events are always separated in two parts, and we will see that more into details during the workshop. There is always like a data part which is unique for each category of event, let's say. So meaning that all the execv events will have exactly the same shape in the data section. And it contains basically all the specific informations related to this sort of event. And finally, the event also has an info section, and the info section is basically has the same layout for every event. And this is where you find like general information about the event, the host it's running on. Here is about the event. Here is about the task, the task running on which actually generated this event. Small note, on Linux, we don't really speak about process. We rather speak about tasks. If you want to make the analogy with the process word that you may have in your head is like see a process as being a group of tasks. And basically, the TGID is the task group ID. So all the tasks belonging to the same process will have the same TGID. And will always have also the same GUID. But we will see that more into details during the training. What you can do in Kunai, you can create very powerful detection rules. I will not go too many into details for this one because we will see something similar during the training. But you can do really complex logic. Here, for instance, we try to match on a very specific information of an event with a really specific value. Oh, again, someone speaking. Sami, do you know if I can like mute everyone by default?
Yes, it's in the settings.
Okay.
I think you have to click on participants. And then you should have an option to mute everyone and to prevent people to open their mic.
Okay. Okay, mute all. Mute all current and new participant.
You can uncheck.
Yeah. Sorry, I muted you.
All right. You can uncheck the. Well, that's fine. I mean, now you know.
Yeah,
Also,
I mean,
a side note: can you also like reduce the video feed that you have on the right side of your screen because it's hiding part of the presentation?
the what? This?
Yes. So you can
Oh,
click
okay.
on like the reduce button.
Okay. I thought you couldn't see it.
You know, we can see all the zoom control
Do you see
panels.
this as well?
Yep.
Okay. Okay, I will put it down. Okay, sorry, I thought like this was like transparent to you. Thank you for this notification. So yes, basically that's about the detection rules, and this is basically the uh, single test that you do on the field of the event. And out of those tests, you can create a complex condition logic that would make this detection rule to trigger, let's say. In this case, it's like this test should be false because it's like not this test, and this one should be true. And we will go into the details. Don't worry, because the syntax might be like a bit scary at first, but it's not that complicated, and especially if you already have dealt with Yara rules, for instance. In the same way you create detection rules, you can also do filtering rules, and filtering rules is basically to keep a context around some detection, because if some of you are working in SOX, for instance, or in CSERT, investigating on alerts and incidents, you probably know that a single alert or a detection is worth nothing if there is no context around it. And basically, filtering events is the way to keep context around detections. And this is typically the kind of events that you will like to store in backend storage infrastructure, such as, I don't know, Splunk, ELK, OpenSearch, or you name it. This was for the event part. You can also configure Kunai to match directly some IOCs without having to create specific rules to match IOCs. This is implemented in a different way, where every IOC is stored in a map, and it's used for a very quick lookup. So every IOC is super fast to match, and you can load really a lot of IOCs inside Kunai without impacting it too much. So this is basically the format of the IOCs that Kunai likes and takes as input. And yes, we will make an exercise to show that a bit later as well. It's integrated with other open source software. It's integrated with MISP, which is developed here as well in Circle. MISP is a platform to store your IOCs, and basically more than that, intelligence information and basically information you want to share. And Kunai can be used to pull IOCs from MISP and directly feed it to Kunai. This is not actually done by Kunai itself. This is like helper script that we use for that. And we will make a particular exercise on this during the training. It's also integrated with Yara, so meaning that you can, on some trigger that you decide, you can scan some files. So which makes Kunai a bit behaving on demand, like traditional antivirus software. Except that you will have to provide the Yara rule for Kunai, and you will have to find basically and define when you want to scan some files. It's also integrated with some network analysis tools through the implementation of the community ID. So we have community ID information in all the networking events generated by Kunai. Basically, it's a flow hashing algorithm that allows to identify network connections. In this way, you can, in theory, depending on the network configuration, because formatting might be complicated to achieve, you can correlate the events you see on your workstation or your server with the information you see inside your network monitoring and network analysis tools. This is like specific. This is not something we are going to cover in the session today, but feel free to explore it by yourself. So the conclusions, and after that we can start with the exercises. So Kunai is open source. It's a Linux-based security monitoring tools. It allows you really to track a wide variety of security events. It allows you to define rules, detection rules, filtering rules. You can load IOCs, and it's also integrated with lots of open source projects. If you have ideas about integration, feel free to open issues on GitHub. We will look at it and probably implement those integration. So thank you for your attention, and if you guys have question, feel free to ask. And I hope you guys are all ready with the environment, so the virtual environment, so that you can follow the exercises. If you have question, feel free to either to paste it in the chat or take the mic.
There are some questions in the chat.
Oh, yeah, I'm sorry, I didn't see. This is super confusing. Why I don't see the chat in this? Okay. Do I have experience with Falco? I don't have like a deep experience with Falco. I already tried it like just a little bit. To be honest, I cannot like give you my opinion about it, because this is like the other question. Uh, for me, it's not achieving the same purpose as Kunai. Kunai is more for really highly customizable threat detection and log filtering, and can be used for forensic. I don't have like the feeling Falco can be used exactly the same way as Kunai. There are definitely some overlapping areas between the two tools for sure. But yeah, I cannot like give you like a really strong opinion about it. I'm really looking forward, looking someone, sorry, who would like to compare all the tools out there. And yeah, there is Falco. There is another one called, I mean, I don't remember if Falco is the one of Sysdig or not. There is something around Sysdig. There is one from Cisco as well, which is called Tetragon, I think. And yeah, I would find someone who compares all these tools, including Kunai, and kind of make an assessment. But to be honest, it would be pretty unfair if one of the guy of this project would do this comparison, because of course it would be biased. So if someone completely external to this project could do it, that would be really awesome. Next question, can Kunai be used to containers like Dockers? It can be used to monitor containers like Dockers, but it cannot be used within a container, which doesn't really make sense, because between containers, basically, they are all sharing the same kernel, and Kunai is running a part of its program within the kernel. So yeah, running something inside the container that touches the kernel, yeah, doesn't really make sense. So the way it should work is that you run Kunai on the host to monitor the running container on that host. So to monitor Kubernetes containers, I've never tried it. I guess some users. Oh, you don't see me. Okay. So yes, one of my users actually tried to run it on Kubernetes, uh, and yeah, I don't know what was the output, but I mean, try to do it, and we are happy to get feedbacks. Can we have the presentation? Yes, of course, you can have the presentation. It's like in the GitHub I showed you. So it's there. I can give you the link. The presentation is here. So here is the presentation, and it were also what, okay. Kunai integration with MISP, do we have to run enrichment option, or it can be automated on the IOC in MISP? And how does it give the results by showing tagging on it? Okay, we will see that a bit later. So maybe it will answer your question. So, okay, good. Is everyone ready with the VM? If not, here is the link again. I can paste it. Will I manage to do it? I paste it again. So here is the link to the VM. And if everyone is okay, we can start with the exercises. So, first exercise is a really basic one. This is just discovering Kunai and what can we do with it. So we should open a terminal. So for those who have taken the VM provided, there is Kunai already installed on your machine. So if you just run this Kunai -h, you should see something. If not, there is an issue. So the first thing to do is to run Kunai. So Kunai needs to run with sudo because it needs to run some program in the kernel, as I said earlier. This is not kernel driver, it's eBPF programs. Can I put this here? No, this is boring. Okay. So yes, it always needs to run as sudo. When we do like the help message, it doesn't need to run as sudo, but if we actually want to get events, we need to run it with sudo. So the first thing to do is to run Kunai like this, which will start monitoring your system. And the pipe to JQ is simply to get like nice JSON output so that it's more readable in the terminal. And the T1 is basically to redirect the output to the file, but also print it to the terminal. So yes, interesting information for the VM. If you want the sudo password, it's circle. I will paste it on the chat. Oh, so it's still downloading. Did it? Okay. Sorry for that. Password circle. So circle. We good. And here it goes. We see lots of events being printed on the terminal. Here it's a lot because I think it's a lot of network connections because of Zoom. So it means it works. This is nice. So what can we see? For instance, in this event, we can see that it's a send data event. So send data is when some data is sent over the network by a program. And here we get some information about the program in the data section, as we saw in the presentation. We have like the list of ancestor of this process, which is Zoom Launcher and which has been probably started by systemd, a service. This is the command line that has been started that actually started the process. This is the path to the executable, and information about the socket it's sending the data on. So it's iNet sockets, so IP packets using UDP from my IP address, which is like the IP of my VM, to probably the Zoom server. And we get the community ID. As I said earlier, this is something we can use for network correlation with the network equipments. And this is like the data entropy of the data transitioning over the network. This is indicative. This is not exact because I cannot process like all the content of the packets. But we can already guess that the data is encrypted because the entropy is really close to 8, which is the maximum, which might indicate either compressed or encrypted traffic. So that's what we can see in just this event. There are plenty of others, and we can look at those. So here, yeah, I'm sorry, I will pop it up in another thumbnail. Okay. Here are the generalities, explain a little bit into details. Basically what I explained during the presentation. It's the overall layout of every Kunai event. So it will always have like a data section. Here it's like elided because this is to describe the command section to all the events. Here, basically, this is the same thing I explained during the presentation, and there are all comments on each field explaining basically what it is. So we have information about the host, information about the event itself, the type of event, which is very important. Type of events, you can find them on the left side. There are all of these. And you can go through them to know more. And task is basically a section of the events that contain information about the task who is doing and generating basically this event. So the PID is the process ID of the task. Task group ID is the thing I explained earlier. So this is something to group tasks together, forming what we can call a process on Linux. And the GUUID is something, it's basically a UUID, which is common to all the tasks of a given task group, of a given process. So we can easily track all the activities of a process, even if it is multi-threaded. Okay, and zombie. It's interesting. This is something that flags if the task is a zombie process, a zombie task. A zombie task is basically process that has lost its parent. In Linux, when you have a process that loses his parents, it gets assigned to the parent to the child of init, and it becomes a child of init, but it may be misleading when you are analyzing because basically you see your process comes from init even though it's not a child of init. So that's why there is a flag that indicates that the process is a zombie. Okay. Here are all the events you can have in Kunai. We'll not review them all because they are a lot. Important one is the start one. It's generated every time Kunai starts and gives you information about your own kernel, the uptime, the Kunai binary itself, Kunai version, and also a hash of the configuration file. Important one, the execv ones happens when there is a process which is being executed. Execv script is the same, but when there is a script which is running with an interpreter, such as a bash script. Exit is when a process exits. Exit group is when all the tasks exit at the same time. Clone, it's when a process is forked or clone. So it's taking the image of the process and create a new image. This is typically what a multi-threaded program is doing. PLCTL is to control the process. Kill, it's when a process is getting killed. Ptrace event is when an event is process is getting ptraced. Init module is when a module is being loaded by the kernel. Module is basically a kernel driver. A BPF program load, it's when an eBPF program is being loaded by the kernel. So this is mostly like you can achieve not exactly the same kind of things than kernel drivers, but you can do a lot of things with eBPF programs, and that is why it's important to monitor them. BPF socket filter is it's when some BPF programs are attached to network sockets to achieve, for instance, packet filtering. This is an example of TCP dump, which is doing this. So this is like a legitimate use of BPF socket filter being attached to a process, but to a network socket, sorry. But there are some malicious uses as well. Mprotect exec is when the memory protection of some memory area is turned to execute. So this is something important when there are some shellcode being executed by malware. Mmap, it's when a dynamic object is being loaded. Like this is a dynamic library. So this is the equivalent of DLL in Windows for those coming from the Windows world. Then you have like a lot of networking related information, such as when a connect happens between the host and a remote address, a network connection. There is an event which grabs DNS queries being made. So this works only on UDP packets being sent over UDP port 53 or TCP port 53. Yeah, nothing like custom can be grabbed by this event. So it's basically all the standard use of DNS. Doesn't detect DOH or things like that. Send data is the one we have just seen. And finally, there are some events related to the file system activity. So read is when a file is read. Read config is when a file is read, but inside /etc. Write file is when a file is written. Write config is the same than read config, but when a file is written inside /etc. File rename is when a file is getting renamed. File unlink is when a file is being deleted, but on Linux is called unlinking. And finally, this one, not finally, because this is the last, yeah, one to the last. The write and close is when a file is written and closed just afterwards. So basically, you can identify when files are dropped. And file create is when a new file is being created. So we have, oh, yeah, well, I have forgotten one, which is IO Uring. IO Uring is like the latest event I integrated, and it monitors all the IO Uring stack, all the IO Uring basically activity, and gives you what kind of IO Uring operation is being done by which process. For those who are not familiar with IO Uring, this is mostly, you can see it basically as an alternative way to achieve syscalls in Linux, but in an asynchronous way. It's the main purpose of IO Uring. It's to enable the Linux kernel to do some asynchronous operations. And yeah, it offers like a lot of APIs like reading socket, writing socket, opening a file, deleting files. Really like almost most of the syscalls. And yes, but also offers like a huge attack surface. So this is something that could be disabled if you freak out about IO Uring. I don't know if no, this is not mentioned here, but there is a kernel parameter that you can basically toggle to disable IO Uring. So here we go with the first, basically the events introductions. So yes, by default, Kunai doesn't log all the events because many of them are very, let's say, verbose, and there are a lot, basically. Like the read and writes event, they can be a lot. So if you want to get all the events, you have to run this command, basically. And I just want to show you something which is interesting, that I believe is interesting. This might not work if you have like set up your own VM. I will explain you why in a short time. This is because it requires a specific kernel parameter to be set up, and we can find it here. This is this. I set it up for the VM you downloaded, and for this VM. It allows basically to attach Linux security modules in eBPF, written in eBPF. And it needs to be, your kernel needs to boot with this, otherwise it's not going to work. I'm just getting power before my laptop is stopping. I'm just coming back into. Okay, that's the time to start again. So for those who were not there when I apologize for this technical issue. And here is what I wanted to show you. So if we run Kunai normally, and we try to kill it, it works. It gets stopped. So this is not ideal when you have like potential malware running on your system. So there is a specific feature which is running in hardened mode, and that prevents Kunai from being killed by other processes. If I do pkill again, now I get permission denied and Kunai keeps running. This is the same for debugging. I think if I do that, attach, it doesn't work. If I try to attach to the Kunai process to debug it, it doesn't work. I get permission denied. And this is achieved by registering a Linux security monitoring hook in the kernel in form of a eBPF program, and that's why we need the specific kernel parameter that I just showed you a couple of minutes ago here. And yes, if you want to use this option, you need to put this in your Linux boot argument command line. And just be informed that if you run Kunai in hardened mode, like here, it won't be stoppable. So if you run it as a service and you want to restart the service, it will not work. So if you enable this option and need to stop the service, you need to disable the service, reboot your machine so that Kunai doesn't start, and finally do the modifications that you need, eventually removing Kunai or whatever you want. But yeah, just to know that when there is this little option, so dash dash harden, to make Kunai run in hardened mode, it becomes unkillable even by systemd or all the basically service management process. So yes, there we go for the first exercise. This was not like mentioned, but we can try to go to the second exercise, which is using Kunai tools. So Kunai comes with a bunch of utilities written in Python, and those utilities you can find them on the Kunai repository as well. Oh, I will show you the link and I will paste it in the chat. So this is like the link to the Kunai tools. You can easily install them with oh, damn it, with pipx or UV. Copy, and here is the chat. Okay. So amongst those tools, there is one which is called Kunai Search. This one is used to search process to search process activity and basically show only a specific activity of a process. So let's do the following exercise. We run Kunai, we redirect the Kunai output as we did previously. We run ls in another terminal. And finally, we stop Kunai. So if we look at the Kunai log, we see that there are already 2000 events, which is quite a lot. And let's assume that in this trace, we want to search the activity of a single process. One could imagine that we use grep for it, but grepping is not optimal because we would grep only at one, let's say, layer. As Kunai allows to track the whole activity and parent-child relationship, this is very interesting to be able to do a recursive search. And that is what Kunai search is doing. So Kunai search is this. It's already installed on the VM you downloaded, or if you followed the install instructions. How? Damn it. It doesn't work. So we can use several options to search the logs. We can search by file. So this is basically hashing the file and searching by hash and recursively updating the task group UID and get the whole activity of ls and its children, sorry. But yeah, ls has no children, so we see only the ls activity by doing this. Which is much more convenient than digging inside a lot of log entries with a lot of noise around. So here, for instance, we can investigate and look at what the ls process has been doing. So we see that it has been started by the bash process. We see the ls command line I just typed. I didn't type this because I guess this is basically ls alias in the terminal. So when I type ls, it's actually this which is run. So that's why we see this. We can confirm. Yes. So this is the ls alias. This is because of the ls alias that we see this. So we see the execv. Then we see that it's loading libs shared library. It loads the classical libc, and you have noticed every time we see like the hashing information of the shared object being loaded. Another shared object being loaded. It reads a file, local alias, another file in the config directory. So we have a read config event. it reads the password file, probably to display like the username information in the ls output. The group file, same reason. And finally, we see that it exits. And the error code is 0. So that's it. We have seen and track all the activity of the ls process. So the Kunai search is not doing much magic. So it's searching by MD5 when we search basically by file, as I did just here. Here mean capital F search by hashing the file. So this works only if the file is on the same system as the logs has been monitored. So there is another way to do it. You can directly search by a hash, for instance. So I'm copying the hash here. And this you can do it with the minus little c, and it gives you exactly the same output. This is better in case you don't have the binary on the same machine. And finally, the last one is that you can search directly by task group UID. So this UID. I can copy. And this you can hit with the minus G. And same output again, and even another event, which is the event just before, which is when bash cloned, because every command bash is running, it first clone its own process and then exec v in the clone. So at the time of cloning, we have already the GUID, which is ready. We don't see it in the two previous cases because we search by hash and we search by hash only forward. So we see the hash here the first time, and then we can track only from this event. So here is the use of Kunai search. This is very important to know how to use that tool because it can be very helpful. For instance, if, I don't know, you want to create a detection rule for a specific sample. So what would you would typically do is run this sample inside a VM or confined environment, basically monitor it, and eventually find some events on which you can create detection rule. And this is much more easier to be able to isolate the activity of a malware sample rather than looking at a whole bunch of logs. So this is why this tool is important to know. Another interesting tool, which is related to log filtering, is Kunai Stats, and which is the following exercise. It allows you to see the event throughput. So it can compute the event throughput from a trace, as we can see here, or you can run it live. We will see that in the next minutes. So here, for instance, we see that there was only one execv event, probably my ls command. There were 5 processes exited, 2 exit group, 4 clones, and like a lot of send data linked to the Zoom presentation. And this notation E/S mean events per second. So this means basically 175 events per second. So this tool can basically help you to size the log volume that is going to be generated by a given Kunai configuration. So here we are running Kunai without any filtering, so that's why there are a whole variety of logs. But very, very likely, if you want to deploy Kunai in production, you will run it with some custom filter to filter the logs. And if you do that, it's probably also because you have a log backend in which you want to store the Kunai logs. And this one comes with limited storage, probably limited bandwidth. So you basically want to limit the number of events Kunai is generating. And you can leverage that tool to see if your configuration is working as you expect. So this is again on the trace file, but we can run it directly on Kunai output itself. So nothing easier. We run Kunai and we pipe it to Kunai stats. And we put a dash. Dash just mean read the logs from std_in. This is like a common notation you see in Linux CLI tools. So again, circle password. And here we see the statistics being updated in real time. And I can do something funny. I can create like a loop. And here we see like a lot of logs being generated with a huge throughput. So here we go with the two Kunai tools, which are Kunai Search and Kunai Stats. We are going to see others in the next exercises. And we are done with this exercise. So if you guys have questions, feel free to put them in the chat and I will try to answer them. Okay, no questions so far. Okay, did it? There was one question about the community ID. I think it's, yes, it's Colite. This is a flow hashing algorithm that allows to identify some network flows. Okay, no question. So we can go to the next exercise. And next one was a break in theory, but we did a break in the previous exercise. So I propose you to move the break after this one so that we do 3 exercises, break, and then the 3 last. So now we are going to learn how to configure Kunai with IOCs. So the goal here is being able to monitor your system and being alerted when it matches a given IOC. So I put here some links to the documentation that you can visit if you want to know more about the configuration and also the Kunai tools that you can use to help you in this task. But first, we are going to understand the way Kunai expects IOCs to be configured. So the format is pretty straightforward. You have to provide a JSON object with a UID key, which is the UID of the IOC. It can be auto-generated. This is not important for Kunai. You give a source. This can be whatever as well. It's not very important for Kunai. What is very important is the value and the severity. So we are going to copy this. Yeah, this question should come after this one. This is weird. I have to update this. So we are going to create an IOC, a file containing the IOC. So if you are more comfortable with using Vim or text editor for doing this, so feel free to do it. I use cat because it's handy in the terminal. So we can verify that it's a valid JSON. It can be parsed with JQ, so it's probably one valid JSON. Then we run Kunai with this IOC file. The way to do this, if we run Kunai without any argument, this is the same as doing sudo Kunai run. Exactly the same. But if we want to put run argument, because Kunai has some like several options, we have to put the run command. So it's sudo Kunai run. If we want to know what argument run command takes, we can do -h and we get all of them. And to provide IOC file, either we put like -i or --IOC file. So this is interesting to note that during this training, we are mostly using Kunai in command line, but all these command line flags can be configured in a configuration file. So because in practice, you will probably run Kunai as a service, as a Linux service. So yeah, just know that all these options can be configured within the configuration file. So we configure it with the IOC file we have just defined. And here we go. And what do we observe here? We see that there are no other event. There is only one event, which is the start event. I will pipe it to JQ because it's pretty ugly like this. So we see only a start event, which is always here. Whatever happens, it should be here. And after this, there is nothing. This is normal because when Kunai is configured either with IOC file, a filtering rule, or a detection rule, it basically assumes that what you want to see is what has been configured. So here we assume that the only thing you want to see is what is matching the IOC. So if we look at this IOC, so the IOC value is circle.lu. So in theory, if we visit something on the circle.lu domain, we should see something happening. So we can try with Firefox. I'm not sure it's going to work because sometimes Firefox is configured with DOH. Oh, it worked. So we clearly see that events, we see basically all the events who contacted and eventually send data to the sickle.lu domain. Oh, I'm at the top, so probably there was a lot. So several send data events. We see the host name, the destination IP, the data entropy, and what we see as well. Maybe I can put this way so that it's clearer. We have configured a severity to this IOC. So when the IOC matches in one event, you will see it appear in a new section that we have not talked about so far, which is called the detection section. And in this detection section, you have IOCs array containing all the IOCs who have matched. And in this case, there is only one, which is circle.lu, but it's possible that there are several, might be for this example, an IP address or a process name or whatever. And you also see a severity assigned to it. And in our case, the severity was configured to 10, so the severity is 10. We can try it again. Oh, this is an error. Uh, if I configure the severity to 5, and I do the same exercise, we see that the severity is now decreased to 5. And we can do something else interesting, is we are going to take this IP address and we are going to make another IOC out of it to see an interesting behavior. So I just copy the IOC. I will change the UID. The value should be the IP address. And the severity, let's say we put it to 3. Okay, let's do it again. Refresh the page. Oh, and we see new IUC match with a severity of 8. So the severity is now to 8 because it cumulates the severity of the two IOCs. So this one was 5 and this one was 3. And this goes for IOCs and goes for a detection rule as well. So the severity is basically accumulated between all the matching. And the severity, we decided to bound it to 10. So 10 will always be the maximum severity. So if I put this IOC to 10 and this one to 10, the severity at the end will be 10 anyway because it's a cap to the value 10. So I can show interesting option as well in Kunai. So here we have the logs, we have the IOC file, but it might be a bit boring to always run the Kunai command to test the IOC file. So Kunai comes with a nice option, which is a replay command. And the replay command just replaces the log and applies either the detection rules, the filtering rules, or the IOC match. So here are the option of the replay command. So if I do replay -e, IOCs, and then I put the log file. And I have an issue. And I have a bug. Did. Ah, yes, I know why. I know why because yes, in the kunai.json file there are structure which is not expected, which is the detection section of the event. The replay command expects like raw JSON event without the detection section. That's why we have this. So let's do the exercise in another way. I will do this again, but without the IOC here. Okay. I'm just redoing the oh, okay, I visit circle.lu. I stop. So here now we have like a bunch of Kunai logs and we want to test our IOC on it. So we can use the replay command and now it should work. Yes, it works. Okay. So here the important to note is the Kunai replay command, which that you can use extensively to test your IOC, your detection rules, and your filtering rules. It's a huge burden to run Kunai every time you want to test one of these. So it's been the purpose of this command is simply to make your life easier when you design all this. Okay, this I can remove. And okay, this we did. Okay. We can use another Kunai tool, which is straightforward to use, which is Kunai IOC Gen. You just give IOCs in the command line, and it creates the good JSON object. So the first expected argument is the source of the IOCs. Then the value, we can put this, and then the severity. And it creates the good JSON object. So why that Kunai tool exists is basically to make the life easier of the people who actually want to create bulk IOCs from whatever format from the command line. So I got some notification on the Discord chat, Kunai, but I don't think that's the proper place to ask questions. Okay. Here we are. We can try it. We put it in a file, even in our IOC file. So if we JQ it, we have the tree. And we can either replay, but replay will not work because we have not visited ykunai.rocks. Okay, so I will run the command line. And if I refresh this page, we should see something appearing. So here is again the start event. And we don't see anything. And what is the reason for that? Maybe it's in the cache, trying to refresh. Strange. Did I do a typo? Ah, yes, I did a typo, that's why. There was a typo. So this is kunai.rocks, not kunai.rock. Try again. Here we go. We have it. So here is basically how you configure Kunai with IOCs. So far, we have seen that it's kind of manual work that we have been doing. So if you are if you want to do a little bonus exercise, you can try to parse a little CSV file, which is this one, and try to generate, thanks to Kunai IOC Gen, the proper IOCs to feed a Kunai. We'll not cover it yet. If you want to do it at home, feel free to do it. Because now we are going to move to another Kunai tool that we are going to use is basically how to use your MISP instance and pull IOCs from it to get the IOCs to feed Kunai. So first we are going to, I'm going to close this one. I'm going to create a configuration file expected by this Kunai tool. So it's okay. Better this way. So I copy, I paste. So this configuration file is TOML formatted, so it's really straightforward, init looking ini looking file. So here is to configure a MISP server with an API. Things we are not going to do because I didn't set up a test MISP server. But if you have like a private MISP, feel free to update the credentials. Put the API key here instead of change me. Put the URL of your server here. And don't forget to enable the server here. In our case, we are going to use a MISP feed. So the difference between MISP server and MISP feed is that MISP feed is basically accessible without any authentication. So this file supports multiple MISP feeds, so you can add several others after this one if you like. This one is the circle one, the circle feed. So we are going to consume IOCs from this feed and create IOCs for feeding, for configuring Kunai. So we have our configuration file, and the Kunai tool we have to use is called MISP2 Kunai, and it's the one I mentioned in the presentation in the beginning. So here are the command line option. We have to put -C to point to the configuration file. And better, we can select, we can use the -L, which takes only IOCs from the last n days, let's say. So if I put 10, it's going to take IOCs from the last 10 days. And here we are. And it takes the IOCs and format them properly so that they can be fed to Kunai. So you may notice that there is an additional field in the every IOC, which is the event UID. This is not an issue because Kunai basically is not very strict about this format. It only needs, and there is type as well. Kunai only needs two information basically, which are the value and the severity. So anything else can be used for bringing context, let's say, to the IOC. This is a choice. I put a type and the event UID so that we can eventually get information back about what event has, what MISP event the IOC corresponds to if we want to do, let's say, a reverse IOC search out of the Kunai logs. So here MD5s are going to be hard to test. I'm going to take more IOCs, let's say 90 days. I will put it to another file, mispiocs.json. And I will run Kunai. Here we are. Always forget the JQ. I'm grabbing a domain IOC for the simple reason that it's easy to test. So in theory, if we do a curl on this domain, it should pop up in the Kunai logs. So that's what we are going to do, or even a dig. Even a dig should work. Here we go. We have it. We see the DNS request for this domain. We even see the response IP. And it generated a detection with the IOC information and the corresponding severity. And we see it dig does request to a local server because it's using the systemd resolve service. So we see that the DNS server here is local to the machine, but systemd resolved is using another IP address. And yes, that's it. We learn how to configure Kunai with the MISP IOCs. So it works exactly the same if you configure your MISP to Kunai tool with this configuration with using your own server. It works exactly the same. And I think if you have the both enabled, it will take the IOCs from the both. Of course, if you want to disable one, you just need to set the flag to the appropriate value. What can I say more about this? Yes, a little bonus. This MISP to Kunai tool can be run as a service. So if you want to have it running all the time and pull the new IOCs without bothering running the command again, you can do it like this. You just put service -L and you have to provide an output file because otherwise it's going to print it to std out, and that's not what we want. So yes, we see that it builds cache from the IOCs it already knows so that it actually updates only the new IOCs. So you could imagine that you have this like running as a Linux service on your box, and so that you get always fresh IOCs for your Kunai. So that's it for IOC configuration in Kunai. If you have any question, feel free to ask them in the chat, and I will answer them. Ooh. Could you please? Okay. Can we use regex in the IOC's value in JSON? No, this is not possible. I need to drop, but thank you very much. Thank you, Maxime. Okay, so no, it's not possible for IOC. So if you want to achieve more complex, let's say, logic on the IOC value, you can use a rule. You can use a detection rule. As I explained in the slide, the way IOC match is implemented, it's an entry in a set, so in a set data structure. So it needs to be an exact value. It would be quite more resource intensive if I would have basically to match the value against the regex. And the more appropriate way to do this is through a detection rule. Okay. If you have other questions, feel free. Otherwise, I propose you to do, again, not a 15 minutes break, because we already did 10 minutes break, but another round of 10 minutes break before the next exercise. So let's start again at 4, 10 past 4, and see you later. So it's now the time to start again and continue with the next exercise. And so in the next exercise, we are going to craft some detection rules to bend Kunai into a threat hunting and threat detection tool. So again, I put some documentation about those. Here it's a generic documentation about how you can create detection rules. And here it's a very important piece of information. It's a bit of a memo about detection rules and filtering rules, and yeah, basically all Kunai rules in general, and the way they are formatted, as well as the operator it supports, the conditions, syntax you can use, and so on. So if you can keep a page open with this memo next to you while we are working, it would be great. I will not do it because I don't have a lot of space on my screen, but if you can do it, do it. It will be helpful. So to start, we're going to create a directory where we are going to put our rules. And we are going to create our first detection rule. So just to explain a little bit the rule and the syntax and the format in the same time. So here is the name of the detection rule. It should be unique because if you have several rules with the same name, it's going to be conflicting, I guess, at load time. And yeah, anyway, it doesn't work at detection if you have several rules with the same name. You must, no, actually that's optional. You have the type of the rule. By default, it's a detection rule. So if you put nothing, it will be equivalent to detection. You can also put filter or dependency. A filtering rule is something we are going to see later on. It's to filter in or out logs you want or you don't want to bring context to your detection. And dependency rules are rules that can be used within other rules. We might be able to see this. This is not more complicated than classical detection or filtering rules. It's just that it's there for performance gain, as dependency rules are always evaluated once, while if you have like repeated regexes here in the matches, they are going to be evaluated for every rule. So within a Kunai rule, you can put some metadata information, such as tags. There is no specific tag syntax, so you can choose the one you like. You can put a Mitre attack ID. Here it's enforced and should be like t some integer dot some integer, basically the way Mitre attack IDs work. You can specify some authors for this rule, and also you can specify some comments. It's always a good practice to put comments to describe what a rule is doing, because maybe only looking at the matches and the condition might be complicated if we are not like the author of the rule. So comments really help other people to understand what the rule is supposed to do. So okay. Finally, we have the match on section. The match on section is where you define the events you want the rule to apply on. The event must be a Kunai event and might be one of these two events. And in this case, this is exec v event or exec v script. Here you can either put event by name, so exec v script, as you saw in the, as you can see, sorry, in the events themselves. So if we do this, oh, this is typically these values here inside the event section, the name section. Basically anything you find under the name field, you can put it here, or you can put the event ID. Event ID is unique per event type. So all the send data event will have the same event ID, so 62. Finally, in the matches section, this is where you define variables. And the variables are basically collecting the results of a test. And in this case, the first test is that we are going to look inside the data section. We have dot data. This is JQ notation. So I took this by convention. Then ancestors. So it means we're going to look at the ancestors field. And this test is regex test. If you look at the memo, you have it here. It's like the regex operator. So the following value must be a string. And here we have a string. You may have noticed that we have like an exclamation, not a question mark at the end. A question mark in regex notation means 0 or 1 repetition of the previous character of or regular expression. So the previous character is M, so it means we match either slash user bin slash vi or slash user bin vim, because M is accepted with 0 occurrence or 1. Here we have another variable with another test, and the test is looking inside the data command line field and searching for HTTPS or HTTP, basically strings. Same with this question mark. It supports matching HTTP semicolon slash slash or HTTPS semicolon slash slash because of this little question mark. And finally, we have to define the condition, the match logic, and the match logic is defined by the condition. And in this case, it's all of them. So it means all the variables defined above, so VI parent and HTTP and CLI, must be true. So this must match and this must match as well. And if that is the case, we attribute a severity of 10 to events matching this rule. So this is like a fictional rule that identifies something that has a Vim parent. So Vim is appearing in the ancestor string, meaning that one of our parent is the Vim text editing program. And one of the child is running some commands with HTTP or HTTPS URL in it. Might be something used by attacker to, let's say, hide their activity. So that's why it's an interesting rule to demo these things. So now we can either we can run Kunai, as we have seen earlier, or we can do the exercise with the replay command. I propose to use the replay command because it's very convenient. So sudo kunai run, and we just put the log somewhere. Oh, I have a Kunai already running. That's true, with a lot of errors. Yeah, I have errors that I have to fix. It doesn't mean there are events missing. Sometimes you can see error like this, but without any events missing, especially for this probe, which is the DNS one, because we analyze the send message syscall, and basically it analyzes all the calls to this syscall and might be related to something which is completely different from DNS traffic. But yeah, it was investigation. So error here doesn't mean like something super critical that make you miss event. It's just like, yeah, not normal to see them, and I should fix the things up. So let's clean the terminal. Sudo kunai, and then Okay. So let's try to generate the log entry that will trigger our rule. So we start Vim and we enter, I don't know, command line with an HTTPS URL. Here we go. We just did like a curl command within Vim. So now we should have generated activities in the Kunai logs. So we see again all the activity because I didn't configure Kunai with any rule. I want to make use of the replay command because it's a very good habit to take. So Kunai replay minus R. We're going to see the options. So previously we have been using the I option because we wanted to check IOCs. Now we have configured a rule, so we should use like the minus R option. And the log file. And here we go. So we see the events matching our detection rule. And as the IOCs, we see that there is a new section inserted inside the event. And this new section is again the detection section. But instead of putting the matching inside the IOC field, we put it in the rules field because it's a detection rules and not an IOC. So in the rule field, you will see the names of the rules which have matched against your event. You will also see some tags, which are the tags you have used inside the rule. So here our tag was this one, so we find it. And you also find information about the attack IDs. Here was T4242, which is fictional as well. And the traditional severity. So, and why do we see several? Yeah, we see two events matching this rule because it's interesting. Vim before it doesn't use like it doesn't execute curl as is by cloning itself and replacing by the curl command. It instead runs a bash interpreter with the command line as argument. So we first spot this command line which is spawned by Vim, and finally we match also the actual curl command. Here we see that it's the curl binary which is executed and not bash anymore. So this rule matches actually two events, not a single, not only one. And yes, of course, we can do the same exercise with the run command. Okay. So here is the same as IOCs. If you remember what I said, is when you run Kunai with either rules or IOCs, it shows only what is matching. So here nothing is matching the rules until I actually I have to Start again Vim. And we see that Kunai actually shows the detection we have just made. Okay, we have covered this. Okay, interesting. We can do the little bonus because we have a bit of time for this exercise. So either we create a new file with the rule, or we can append it in the same file. I will just show you. If we want to put several rules, we have to put this separator because it's YAML-based format. If you haven't noticed, so the separator between YAML documents is this, the 3 dashes. So you can either do this. It should work like this. Yes, the format is valid. Or you can put this in a separate file. It works as well. So I remove it. And I put it here. So let's try to understand what this rule is doing. It's pretty straightforward. Contrary to this rule, we see there is no match on. So match on means match on only some Kunai events. So here there is no match on. So by default, it's going to match against all the Kunai events. And here are the variables, and they are looking for TMPFS-like or TMPFS known path, which are TMP /dev SHM run var, which are often used by attackers to drop malware. And basically, when either something is running from TMPFS in the ancestors or in the binary path itself, we attribute a severity of 2 because it might be a legitimate activity. So having a high severity for this kind of detection might lead to lots of false positives. So that's why the severity can be rather low. So we can run Kunai again. We are going to do something else, which is copy curl into another path. So we copy the curl binary to /tmp and we name it C. So if we do C dot circle.lu, oh, of course it doesn't work. It does the same thing as curl. And what do we see? We see already that there are some detection, but with very low severity because we are running stuff from TMPFS. Actually, that might be the good opportunity to show this command line option. In the Kunai command line, there is one option that allows you to show, and again, that is something you can specify in the configuration file, a minimum severity of the detection you want to show. So if we decide that severity 2 is too low to be relevant, we can decide not to display them by saying mean severity maybe 5. We say above 5, it's interesting to see. And again, detection, rules detections, and JQ. And here, if we do the same stuff again, we will not see the detection. It doesn't mean it's not scanned or it's not analyzed or doesn't exist. It just means it's not displayed. So let's try to do the exercise again. We do Vim. And here we used our drop binary in TMPFS. And now we see a detection. And we see a detection because it's above the 5 severity. And we see the severity is now raised to 9 because it cumulates the severity of this rule and this one. So 7 plus 2, 9. And we see that they are the two rules inside the detection sections, along with the tags. And we also see that the attack IDs are accumulated inside this slice. Okay. So that's all for the detection rule. And to get back to the question of one of the participants, if you want to match regexes against some domains, for instance, that's the way you should go for the moment. There is no alternative than doing a detection rules if you want to match regexes. So if you guys have questions, feel free to ask in the chat and I will answer them. Otherwise, we can go to the next exercise. Okay. So the hardened monk could be defeated by sending. Yeah. Yeah. That's good. But the purpose of I mean, Kuna is not like really supposed to work in command line. So the hardened mode indeed makes a lot of sense to be used inside to be used as a service. Anyway, yeah, I don't expect people to run Kunai as command line in production, so in a terminal, I would say. So yes, this is basically the same as sending, yeah, as you said, Control C in the terminal. We saw it that here, if we do, would I sudo, sorry, if I do sudo Kunai run harden, so here I'm still able to stop it. So I do Control C, so it's handling Control C interrupt. So yeah, I would say that it's a normal behavior of having it like reacting to the Control C uh, interrupt. But thanks for this nice poke in C. Really cool. I don't have a thumbs up. My God. Okay. In statistical term, can Kunai detect a compromised server? For example, by analyzing the frequency of event types. No, Kunai cannot do that by itself. But if you have the Kunai logs, which are stored in whatever log storage backend, such as Splunk, OpenSearch, ELK, you name it, this is probably the kind of detection you can implement quite easily. I would say that it's pretty hard to implement it because yeah, it would need some learning phase, and basically it's really different for every machine. If like it's HTTP server, probably it's not going to have the same behavior as another application server, for instance, or developer workstation. So I have the feeling that it's probably the kind of logic, detection logic that you rather implement in your log query system. Okay, our Kunai detection rule will be shared by Circle in the future. Yes, there are already some. There are not a lot because yeah, I'm busy with Kunai development and all the rest. So I try to develop some rules from time to time. They should be there. Community rules, yeah, easy. So you will not see anything in this main branch because it's organized by Kunai version. There is no rule for the V06 for the moment, but the V05 rules should be all compatible. And you have some here. But yeah, that is something I should definitely do. How it should be used in production, not by terminal. Okay, it should be used as a service. So so for the little story, I will show you this sudo kunai install. On purpose, I didn't want to, this was initially planned, but I prefer to focus more on the, let's say, specific Kunai aspects for this training. I didn't want to take too much time with Kunai installation, but the Kunai install command can install Kunai as a service, as a systemd service, and enable it straight. So I will not run it because install, if you do that, systemd and systemd, yeah, you don't even need to put the unit, and enable unit. it is going to install systemd as Kunai as a service and enable it right now. So it will run and put the logs in according to the configuration file. The configuration file, you can find it in etc kunai config.yaml. Oh, in Vim, it's better. So where you can basically configure whatever you want. You can configure the output, you configure the path to the logs, which will be in var log kunai and events. The log will be rotated every 10 megabytes. The directory will rotate when the size will be 1 gigabyte. It's not mentioned here in the config, but the files are going to be compressed in JZip. And yeah, basically that's it. And this is the way Kunai should run in production. Because that's where you configure the rules, that's where you configure the IOCs, that's where you configure your Yara rules, the minimum severity, and some other information such as like enabling or disabling events. This is something I didn't mention, but you can completely disable events, meaning that they will not exist, they will not load the system. So if you basically disable events, yeah, it will reduce the impact that Kunai has on the system if it's an issue. Meaning that any event which is disabled will not go through to the rule matching engine, which is obvious. But if you have detection rules or filtering rules which are discarding events, they're still creating loads on the system because they are still getting generated until they go into the rule matching engine. So yeah, for the little story, I hope I answered your question, Elio. So yes, I didn't want to lose too much time with Kunai installation as a service because that's pretty straightforward way to install stuff on a Linux server. So if you want, I can just put you the reference about it in the chat so that you have it. You go to the Kunai documentation in installation, and everything should be documented, including the fact that you should be careful with the dash dash harden option. Because as soon as you enable it in the service, it's not going to be stoppable by systemd. Okay, here we are. This we covered. Finally, next exercise is log filtering. So log filtering is exactly the same philosophy as writing a detection rule, except that the rule will not be marked and basically flagged as detection. It's rather to, as I said earlier, to keep context about a detection. Because as we have seen in the previous examples, for instance, if I do that, let's do quickly the exercise again. We see that Kunai generates two events. I've been part of a CSERT, and I can tell you that if the SOC comes to me and tell me I have a Kunai detection With this, without anything around, it's going to be a nightmare. It's going to be a nightmare to investigate because I have basically zero context around it. And so this is why, and this is where log filtering comes into play, is to bring context around detection. Because the context is basically what allows you to make the difference between a false positive and a real alert. So we can create a new location for our filters if we want. And so I would say that log filter tend to be a bit easier to write and should be less in number than the detection rule because basically you configure it once and you don't touch it anymore because you always want the same kind of logs for keeping your context. So what can we do? Okay, yes, I can do that. I will not follow the exercise. I'm sorry. I will diverge a bit. So here in this example, it's called include all but noisy. So it removes some mprotect exec event and prctl events, which might be noisy. This notation, when we put a minus in front of the event name, means take the rest but this one. So we can do something funny. We are going to remove exec v. This is just for the sake of the example. This should probably not be done in production. Okay. So let's do this. Our Kunai stat stuff from we're going to reuse what we have done earlier. So here's a loop that execute ls. So it's generating a lot of execve. And in theory, if now I am applying my filtering rule, because we have removed execve, we should not see them anymore. And you see the ls command is still running, and we don't see any execv event. So this is also to show you. So in here, of course, the log throughput is has decreased. We see we are at 1,300, and before we were at what? At almost 2,000. Yeah, less. 1,500, 1,600. So yes, here we see that it's very interesting to use like the Kunai stat command we have seen earlier to see if our filtering policy works properly and if it impacts the event throughput as we expect. Because yeah, I've been like challenged in the past. I remember I had like to decrease the number of events per workstation to 10 events per second. So this is typically the kind of tool you have to use for being able to size this throughput and to understand your logging policy and the impact it has. Okay, so let's modify the filter because this one is not very important. We can imagine a filter which is for DFIR, for incident response. Ah, damn it. Uh, what could be interesting for incident response? Any incident responder in this room? No? In the chat, which event would you like to have? Tell me. I'm looking at the chat. Tell me what you like. Yeah, okay. Of course, Kunai doesn't help with phishing campaigns. I'm sorry. We can look at the event lists. So what I would like, execv script, exit is interesting. Exit is interesting because we can know when a process stops. For instance, it might be interesting if we have like a malware or something and it failed at running. So we should see an execv and an exit straight after, which might not be the same, let's say, action you would take as if the stuff runs from several hours or days. Okay. Kill, ptrace might be interesting. Basically, all the events which have low volume are interesting to take, especially kill and ptrace. So you don't have like kill and ptrace event all the time. Init modules as well. BPF program being loaded. This is cheap. Again, I have to stop snapshotting. Uh, this one, I don't remember how it's called. And map exec is taken. Okay, let's say it's not bad. Yeah, and this one. This one is nasty. So here we don't need to specify a condition because simply we don't want to match complex logic in the event itself. We can do it. There is no issue with this, but just that if we want all the events of all the process, there is no need to apply complex filtering. So let's try to run it. I hope I didn't do any typo. We can already stat. And we see that we kind of already shrinked the event volume, but we have to remember that we still have our endless ls loop, which is running, which is not like realistic. But even with the loop running, we like shrinked by half the number of events per second, which is already interesting. And here it's not updating anymore because the throughput is like so low that maybe I need to refresh only every 10 events. Yeah, even though this little minus R means we refresh the Kunai stat output only every 10 events. And we see that it's even not enough because we don't see anything. And I don't know why it was not refreshing properly. Okay, so normal use, we are like 200 events per second, which corresponds to, yeah, this throughput in terms of kilobytes uncompressed. So yes, this can really gives you a good insights on what you can expect on your storage side. And by doing this, we keep like very interesting events. I can put it in a file. What did I do? Yes, I wanted to keep it in the terminal as well. So yes, interesting fact, and this is new in the latest Kunai version. It's that we have filter information in the output event. So instead of having like for the detection, we had detection section for filters, for logs which are filtered, sorry. We have the same ID of keeping the track of the filter that matched. This is interesting for debugging purposes because this is something I've put here, which is important to remember, is that Kunai rules have a OR relationship between them. So it means that if you have a filter rules that exclude some events and another one that include it, it means that you will see the events at the end. But if you don't have like this information and the information, especially about the rule that included the events, it's really a nightmare to figure out where it comes from. So that's why I decided to also integrate the filter information inside filtered logs. And you can also tag some events. So it might be interesting if you want to tag some specific activity. I don't know, you can imagine whatever, like tagging stuff executed by privileged user or users having PIDs above or below 1024, something like this. I don't know. You can use it for whatever you like. So here is how you design some filtering, some log filtering. So I'm done with the log filtering. The thing you have to remember is that it's very similar to the detection rules. This is the same syntax, the same way to build the detection rules, and that it's really used to keep the context around your detections so that you can actually understand what is going on around some alerts. So if you have questions about log filters, feel free to ask. And again, I will try to answer. Alors, so I have, yes, I want to tap. Ooh, this is a very specific question. Dark web traffic, I think you could kind of do it if you have a database of IPs which are typical of dark web. Except than this, I don't see how to do it. I would have to think about it. This is not something I've thought about so far. Maybe you could write a rule to find Tor network connection or VPN. Okay, I guess it kind of relate to the previous question, and I would go for the same answer. Um, yeah. The way I'm thinking is that you need a database of IP you want to track. Without it, I think it's going to be difficult. Unless you know some programs who are doing this, and so that you can directly track the program or program name or something like this. But if you really want to identify the traffic, you need, I think, a database of IP addresses. But we also look for PowerShell commands to see any sign. Na. Okay. And is Kunai helpful for live forensics? I think it could be, yes. So interesting stuff that I didn't mention, but yeah, that will not work here, is that when you have Kunai running as a service, you have a nice command line, which is Kunai logs. And when you run Kunai logs, but this requires Kunai to be running as a service and using like outputting logs to files, it will show you the Kunai logs on the terminal. So this is probably what you could use in live forensic if you have an access to the machine you are doing the investigation on. So this is an option for doing live forensics. You connect on the machine and you run this. The other option is like having your Kunai logs flowing in real time inside your log storage. So that you actually don't need to go on the machine and type command lines. This is not like what I would call live forensic, but this is something I've been using like a lot when I was doing incident response, and yeah, it was very, very helpful. Having the endpoint logs or and workstation logs, generally speaking, it's like endless value. You don't need to do like some complex disk acquisition, some memory acquisition. 99% of the cases can be understood just by investigating the endpoint logs. So in essence, we need to know what we are looking for, or at least an overview of what malicious activity may be present. Yes, that is not. I will show. So yes, Kunai is like a solution that you can bend to your needs. If you have like, if you are doing threat hunting, threat detections, and you probably know what you are actually looking for and what are the behaviors basically which are suspicious. And yeah, we can think a bit about the existing solution currently. How it goes is that you buy a solution from a vendor. It provides you some rules, and most of the time you don't really know why they match or why they don't match. And yeah, Kunai is completely the opposite. It's basically something that you configure to match what you think is malicious or is suspicious. So of course it's a little bit more work, but you really master your detection solution from end to end, and you actually understand why something matched, why it didn't match, and yeah, you basically control everything. The downside of this is that if it fails at detecting stuff, you are the only responsible. You cannot basically delegate the responsibility to XYZ company. It's because you failed at detecting something. But yes, we believe that if with Kunai you have the appropriate detection rules and you have the appropriate detection filtering rules, you can already do a lot. Because what would typically be implemented in production is that, as I said, you have for confirmed detection or for confirmed suspicious behavior, you have your detection rules, but you have also your filtering rules on which that you store and that you send eventually to a CM, and on which you can first do retro hunting. So if you have observed like a specific technique used by an attacker, you can retro search into your Kunai logs. Out of this, you can build new detection rules, and on the logs that you have filtered, let's say execv, all the one you want, you can run some detection scenarios continuously inside your log storage. So if you have your logs in Splunk, OpenSearch, whatever you prefer to use, you can constantly rerun detection scenarios on the logs you have sent in this backend. So yes, this is how you would typically work with Kunai. So how to monitor specifically container activity with Kunai? So to monitor, I mean, you mean only container activity, Jean-Marc? Yes, only container activity. So this can be achieved by filtering logs, for instance. If we look at the shape, of the event, you will see here inside the info section, you will see information about container. Here, it's been this event for documentation has been caught inside a container which had the host name Ubuntu Kunai test and which was a Docker container. So basically, it's not very complicated to find something running in a container. Is that you have to look for this object not being empty. And this you can do it, for instance, I just did it a couple of minutes ago by doing something like this. You have to check that the container is some means it's not null. It's not something you cannot see. As for instance, here it's even not null. Here it's null. So the fact that you make this check is some, for instance, you exclude everything which is null. Here is like for anything that has like also a not null container type, which is the case here, for instance, as we have seen. And here is the rule there is just to identify a Docker container. So we check that the container type is actually Docker. I would just like to make a small note about container. Container is just an abstraction. It's a name around several features used in the Linux kernel. And this concept in the Linux kernel, which is used within container, it's actually Linux namespaces. And the Linux namespaces is to isolate some parts of the process from the others, which are typically the network stack, the PID file system, the networking, the virtual file system as well. So this is what we call a container. But there is no such a notion of container within the Linux kernel. And there is neither notion of container within Kunai. This is just what I'm trying to resolve from what I know about the Linux namespaces. So yes, that's about it. That's why you might have sometimes some weird things like that. For instance, there is not only Docker Docker, Kubernetes, and all these very well-known stacks which are using containers. I don't really like the word container. For instance, systemd has its own process isolation as well, where you can isolate on, as I said, file system, PID, network stack, and so on. And this is actually a container as well. So you would see this as a container here, and you would get some such information in the container field about some hardened systemd services. So yes, that's about it for identifying containers. So basically to identify container, so meaning some processes making use of Linux namespaces, you can identify it with by filtering on this field and this object within the event. Is that okay for you, Jean-Marc? Is that clear enough? Okay, I take silence for a yes, that it's clear. Finally, we can walk through the last exercise so that you kind of get and know maybe 99% or at least 90% of what you have to for running Kunai. It's not this is not this one. This the one we've just done. Okay, this is a bug. I should change the link again. So we should not go to this exercise. We should go to the Yara config. So in this exercise, we will learn how to configure Yara with Kunai. So Yara, it's a pattern matching tool, which is used mostly by incident responders and people doing threat hunting and so on. So it's a tool that you configure with some rules, such as this one, that are matching binary patterns inside files. So Yara comes with a command line tool, which is installed on your machine, which is called Yara, to which you can provide um, a rule set. And it also comes with the library, and the library got integrated into Kunai so that Kunai can actually use directly Yara rules to apply pattern matching on some files. And that's what we are going to do. So actually, before doing the Kunai rule, we can already work with the Yara rule. I will copy it into a file. I name the file ls.yar because it's a file that detects actually /bin/ls. This is for sake of demo. It's not like very relevant to do so in production. But yeah, you can replace it with any rule. To verify the Yara rule works, and actually we can actually try to understand first. So this is the way you define a new rule. So it's rule, the rule name, then you have to open a curly bracket. Then you have different section inside the Yara rule. You have first a metadata section where you can describe your rule, you can document the author, you can document various metadata about the rule itself. Finally, then you have the strings section, and the string sections contains variables. And as you can see, it kind of looks like the way you define rules in Kunai. Actually, Kunai got inspired by the Yara format and not the way the other way around. That's why they look similar. And so here we have two variables, one which is elf magic, which defines a set of different bytes to match. This is actually ELF and the character with the 46 hexadecimal value. I don't know what it is, but this is the elf magic basically. If we do xdd slash bin ls, of course, this is not the good command line. This is matching this. 7F, 45, 4C, 46. So actually this is F and this is the 7F, which is not a printable character. So elf magic, and finally this is a string we can find inside the ls binary. And we can easily find this by running strings and followed by grep. Okay. This is the string we found inside the ls binary. So to sum up, this Yara rule is actually detecting the ls binary. And the condition to do that is that you find the elf magic at offset 0, because the magic elf is always expected to be at the offset 0 of the file. And then ls strings means that in all the rest of the file, we must find this string. Let's verify the Yara rule. So we can scan the whole bin directory. We have several binary matching. And I think this is because we have such a weird, yeah. So, okay, it also matches vdir and dir, not only ls. Doesn't matter, not very important. So we verified that our Yara rule is actually detecting the ls binary, matching the ls binary. So what we want to do with Kunai sometimes is that we want to scan files, maybe files on which you have suspicions, maybe files running in TMPFS, for instance. And that's what we are going to achieve. So let's copy this rule. So so here we are making use of something I talked about earlier, is that it's called dependency rule. I will describe it here, it's more convenient. So here, if you look at the type of this rule, it's tagged as dependency. And dependency rule, it means it's not going to match itself and generate any detection or filter, but instead it can be used within other rules. And for instance, this rule, we are going to use it within another one here. And this means this variable will be set to true if this rule is true, which means that if P or A that we define here, one of them is true. So why it is interesting to have dependency rule? Because let's make the assumption that we have several rules wanting to check stuff happening in TMPFS. What you would typically do without dependency rule is duplicate every time these two checks in every single rule. First of all, it's how to say it's boring because it's a lot of copy pasting. And secondly, it also means that in every rule, this match will happen, which in turns it's like, yeah, it could be deduplicated and yeah, it's duplicated checks basically. The way of creating dependency rule allows you to offload these repetitive matches inside smaller rules that you can reuse. And this is for the good because these dependency rules are evaluated only once. And once it matched or not, we can reuse the results in all the rules. So for instance, here, I only have one rule, but if I have several rules having this, it will always fetch the results of this rule and not reevaluate constantly the same regexes. So it's better for performance, better for documentation because it allows a lot of deduplication. And yeah, that's pretty good already. And it also simplifies a lot like the rules because if every time you have like to specify one or several uh, long regexes, it gets a lot complex. And it's also better for documentation and usability because you have one single place to update the rule instead of having to handle the regexes in several rules. So yes, I strongly encourage you if you want to write Kunai rules to use a dependency rule when it makes sense. So what it does here, it's pretty simple. So this rule, scan tmpfs run, it's a filter rule that applies on execv and execv scripts events. And that becomes true, that matches when there is something running inside tmpfs. So either the binary is running itself inside tmpfs or one of its ancestor is running inside a tmpfs. And you may have seen this. This is something we haven't talked about so far. It's an action that you can define to apply when the rule is true, when the condition is met. So it means when this rule matches, we will make the action scan files. And scan files, it's an action that takes the Yara engine, which is embedded into Kunai, and scan the files with it. When I say scan the files, I put a S to files because it depends on the kind of events. So what I mean is that if we look at execv events, if the event which is matching is an exec v event, we are going to try to match the parent exe and the child as well. So the current running process, which are two files. If, for instance, we are looking at a, I don't know, write close event, where it is, no, not this one, or file create, it works as well. We are going to match the executable path. We are going to scan the executable path, but also the file that has been created. That's why I say files, because depending on the events, it might scan several files. For instance, where you have only one file, the exit event has only one file, which is the binary, the executable binary itself. So in this case, there would be only one file which is scanned. So let's go. We have the Yara rule, we have the Kunai rules defined. We have verified that the Yara rule works. And then we can do this. So sudo Kunai run minus y. Y is to specify the Yara rule. And R is our Kunai rule. I don't remember the name. I put, damn it. Okay. Here we go. Forgot the JQ again. Always JQ. So in another terminal, what am I doing? I am running this command line. And what this command line is doing, it's taking the ls binary, copying to a file which is called blip and which is located in /tmp. If it works, I'm using the timeout command. I'm using the timeout command because this one takes a while to run. And I'm running /tmp blip minus R, which is recursive ls on the root. So after 3 seconds, it should stop. And what do we see in our Kunai logs? So we see our filter, which is matching, scan tmpfs run. It's running the actions scan files. So it generates the events and tells you that, okay, guys, I've made this action related to these rules, and I'm running it on this event. And then what do we see? A new kind of event appearing, which is what we didn't see so far, which is a file scan event. And the file scan event gives you information about a file which has been scanned. So the path of the file, some metadata about it, all the cryptographic hash, the size, and the Yara signature that has matched. In our case, there was only one, and we can verify that by looking at this value. Positives 1 means the number of signatures that we have seen. Why this field exists? It's because it's easier to then run detection rules on such a field, we can say, okay, positives field above 1 instead of walking into the signatures field. So it exists so that we can actually make detection rule based on this event. Because what I've not mentioned is that once the file scan event has been generated, it also goes through the event matching logic. And we are going to see that straight after. So here is the file scan event. Interesting thing is that if you don't have any Yara rule loaded in the Yara engine, you can still use scan file action, but instead of having something inside the signatures and having a positives field above 0, it will always be 0 and there it will always be empty. That's it. But all this information you will still have. Yeah, in an interesting field in this event is the source event, so that we can correlate back to the event that actually generated this event. And this should be the same event UUID than the previous one. We speak about the event ID, which is here, and which is unique by event. So if we want to grep or search inside the Splunk or something, this is like a super fast match. So here is how you use Yara with Kunai. And there is something I want to show you, which is in the bonus, and which will also illustrate what I just said before, which is the fact that the file scan event goes to another round of scanning inside the event matching engine. So we can add this rule at the end of this file. So typically what is it doing? The name of this rule is positive scan. It's a detection rule because we want to raise an alert based on that. It's matching on file scan event, so the one we have just seen. And it's matching if the value at data positives, it's above 0. So meaning that we have at least one Yara rule that matched this this sample. One of the paths, at least. So condition, all of them could have been one of them or whatever. And we take a new action based on that detection, which is kill. And the kill action is supposed to kill the process that generates this detection. Let's see if it works. So, okay. We run Kunai with the detection rule as usual. And now, if I run the previous command, I should not reach the 3-second timeout. Yeah, you see it's killed directly. And Kunai is nice because it tells you that it killed the process. This you would typically see in your service logs. Here's like included in the std out, which is a bit ugly, but this is written to stdr. So yeah, you should see this in your Kunai service log. So here we see several because I run the command line several times, and we can maybe time it, try to time the time it takes to kill the process. Yeah, if it's correct, it's killing it very fast. Which I believe it's even too fast. Okay. So it takes, yeah, 100 milliseconds to kill the process. So that's it. In this last exercise, you have been introduced the concept of dependency rules to make your rule simpler, more manageable, and easier to maintain. You have been introduced also the concept of Yara rule scanning and the wider concept of applying actions on either detections, as we have seen here with the kill actions. And actions can also be run on filters, as we have seen here. We have a filter type of rule. Interesting note about this is that kill action cannot be, in theory, if there is no bug in the code, should not run on filter events. The reason is simple, is that we believe that the kill action should only happen during detection and not on a filter. It's kind of a guardrail. So that's it for me, and that is it for the Kunai workshop. We are very nice in the timing because we are around here and we still have 10 minutes for a Q&A session and feedback. So guys, you can turn on your mic and speak, ask questions, and maybe I can look at the chat before if there is any question. Many people have to leave. Okay, no question. So for the remaining ones, feel free to ask questions, feel free to share feedbacks. And that's it for me for today. I was very happy to teach you all this stuff about Kunai. If you have questions, issues, don't hesitate. You can ping me. You can open issues on GitHub. There is a Discord chat about Kunai, so you can ask questions there. I help people basically. So yeah, feel free to ask if you are in trouble. Don't hesitate to use Kunai, make the promotion of Kunai. And yeah, that's it for me. Thank you.